All right, so we were 23 on the part 2. So let's wait a little bit more for the others. Okay, so that's good. From 21 became 23. And also, while waiting for the others, do you guys have a question so far?
None, sir.
None, sir.
None, sir.
All right,
Answer.
it's good. And also, while waiting for the others, so please try to have an advanced analysis or analyzation on our solutions. What are things that happen? So from here, we've applied absorption, and then what's next? Do you guys have our copy of the calendar? The calendar of the school? Do you guys know
No,
when? Yes. Do you guys know when is our midterm exam? Because if I'm not mistaken, that's 28, January 28, 29, and then 30. Or 27, 28, 29. So it seems like we now only have 3 meetings left, 2 or 3 meetings left. So I hope we can finish the module 1 next meeting and then start with the module 2 next meeting also. So how many are we now? 19. So 4 more. So we will wait 2 more minutes for the other 4 students. 20. So 3 more. Right. So I'm just curious, is there someone here who haven't went to UC yet? Because I know that some of you are first years and then uh, just enrolled the first sem of first year. So maybe some of you haven't went to UC yet, or all of you here already went to UC.
I haven't,
All,
sir.
sir.
You haven't yet seen the UC personnel. Is that you,
I
Mr. Mas?
mean,
Mr. Awas?
I saw,
You saw the
sir,
picture. You haven't seen the UC personally yet.
the inside, sir.
The inside, just the outside. Because I know that some of you are for uh, maybe 10 kilometers, 10 kilometers, 10 hours rather. Because some are, I don't know the names of the places. Like for example, some of you are from Cebu, Ilocos. So those places are quite far. Okay, and then some of you have just enrolled via ODL or online distance learning. Okay, and then since yeah, it's online distance learning, so you don't need to go to this school. And then I'm just curious, so maybe yeah, you haven't yet seen the inside or the gate of UCs yet. Maybe in the future you'll go see the UC, but right now maybe not yet. So one example is Mr. Awas. So you haven't seen the inside of UC yet. So you will see UC soon as COVID is over. Right, so how many are we now? So 22. So I don't know what happened to the other one. Anyway, so let's now continue this one. So from here, after applying absorption, so we've applied here commutative. So we've just interchanged their positions. Okay, so commutative is number one of our laws of logic. Okay. So are we clear on this one? We've just applied commutative. Okay, we've just interchanged the positions of those two variables. Gets or no? So that I can explain this one a little bit more on how we've come up with this one.
Gets, sir.
Okay. And then from here, we've applied distributed properties or distributed law. Okay, so we'll just distribute this negated r into this parenthesis or in this expression. So negated r times r is this one, and then negated r times p is now this one. And then take note, whatever is the one that is outside will now be the one that is inside. And then whatever is the one that is inside rather is now the one that is outside. So that's the positionings or the format of our connectives. And then from here, you can actually evaluate this one using inverse laws. So assuming that we have a true value of r, so if we have this kind of expression, then the result will be always false. Okay. And then from here, okay, what's next? So from here, we can actually remove this one already. Okay, am I correct? F or not R, and then F and not P. Yeah, so you can actually apply distributed properties, or you can directly remove this one since this one is OR. Okay, so you can actually use the, where is that one, or this one. You can apply identity loss. Okay, so even though we have false here, so whatever is the value of our p, so that's the deciding factor. So in here, it's quite similar in here. So we have or and then false, and then our deciding factor of our final value is the negated r and p. So we can just simply remove this one, okay, by applying that rule. So that is why we now have not q and not r and p. Okay. And then lastly, you can apply commutative so that you can have this kind of arrangement, which is P, Q, R, which is now the same. No, this one is not proving whether this one is equal to this expression. So it's just basically simplification. So actually, you can already have this one as your final answer. But if you want to have a better arrangement, like alphabetically arranged, so you can have this one either. So did you guys get this one or not yet?
Got it,
Sir,
sir.
understood.
All right. How about the others?
Understood, sir.
Understood na, sir.
Great. So I really hope so. And to those people who are not responding, so I wish I can see your faces so that I know that you really understood it or not yet. Okay, or it's either you're just doing other things. Anyway, so that's it for this example. So let's now move on to your quiz number 1. Okay, so simplifying the following expressions. So all you need to do is simplify the following expressions. So 1, 2, 3, 4, 5 by applying the laws of logic. Okay. So again, strictly use only the laws of logic. So if that kind of formula is not part of the laws of logic, then do not use that law. Okay. So do not create your own formula. Strictly use our formula, which we have just discussed on part 1 and part 2. Okay. And one more thing. So use Microsoft Word in answering this one. Okay. So no handwritten. So some of you might maybe get mad or didn't like in answering this one in Microsoft Word because it's quite a hassle in typing and then putting some connectives. But bear with me, guys, because if you're going to do it handwritten, okay, I'm the one who's going to have a hard time in checking your papers. So I'm not saying that your handwritten is difficult to read, but in some cases, some of you has a lower pixels of camera. So yes, you have a good handwritten, but the clarity, okay, of your camera is not that good, and I won't be able to read your solutions properly. Okay, so for us to have a better presentation, so just do this one using a Microsoft Word. Well, actually, you can start with papers. So once you're done in doing that on the paper, then that's the time that you can just transfer it onto the Microsoft Word, so that you won't be having a hard time in typing and then looking for the connectives on the equations or statements. Okay, so are we clear on this one so far?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
So again, use
Yes,
Microsoft Word as your final file that you'll be uploading in this quiz. Okay, so moving on, we have here contrapositive. So we have already discussed this one in the laws of logic, but in here we're just applying this one in a readable statement or readable expression. So reverses, or this contrapositive is reversing the roles of P and Q. So again, this P will become our conclusion, and then this Q will become our hypothesis. Okay, and then at the same time, you have to negate each of them. So the contrapositive of P conditional Q is that Q conditional not P. Okay. So for example, we have this statement: if the network is down, then John cannot access the internet. So in here, you have to break down those statements. Like for example, this one: the network is down, then that is already our first variable or first statement. And then John cannot access the internet, which is now our letter Q. John cannot access the internet. So symbolically, if you're going to read this one, you'll have this kind of symbol, P conditional Q. Okay. And if you're going to apply the contrapositive, then you will now have this kind of expression. So Q first, and then in a negated way. So John cannot, so from here, cannot will become can access the internet. Then the network, so again, you have to negate the P. So the network is down, so you have to put not. Then the network is down. Okay. So super easy. It's just that you have to interchange those two and then negate each of them. So now the result is if John can access the internet, then the network is not down. Are we clear so far regarding with this one?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
So this one is super
Clear,
easy.
sir.
This one is very comprehensible. So moving on, we have here converse. So this one reverses the roles of P and Q in P conditional Q. Okay. So contrapositive, you're going to exchange and then negate each of them. But for converse, you're just simply going to exchange or swap the hypothesis to conclusion, then conclusion to hypothesis. So from P to Q, it's now Q to P. Okay. So same example. If the network is down, then John cannot access the internet. And then we have here the two parts of the statement, which is letter P and then letter Q. So if you're going to answer this one using a converse, okay, so if John cannot access the internet, then the network is down. Okay. Without negating the variables or the statements. So are we clear on converse?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, very good.
Yes,
Moving
sir.
on. Let's have a sample problem here. So let S be the statement. If you are studying hard, then you are staying up late at night. So we have here question number 1. State the converse of S, okay, which like what we did in past examples. So converse is just having this one. So P to Q will become Q to P. So could you please answer this one? So I will call someone. Mr. Janeza. Are you there, Mr. Janeza?
No, sir.
Could you please state the converse of S? Okay, which is this one? How is it, Mr. Janeza?
May example pa ba, sir, na iba?
We've just
Example.
discussed examples. This is example of converse. Di ka nakikinig, no? That one is really super easy.
Sige, sir. Ibalik doon sa, yan. PQ. Doon lang naman sa quit, sir. If you are studying hard, then you are staying up late at night.
Is that your final answer?
Sir.
Mr. Janeza, is that your final answer?
Yes, sir.
Incorrect. Okay. So tawag ako na iba. Okay, how about you, Miss Mariz Galigas? Would you please answer question number 1?
If you are staying up late at night, then you are studying hard.
Okay, very good. So that's the correct answer. So Mr. Janeza, so this is the original statement. So if it's already converse, then it should be this one. Okay, it's the opposite. Okay, so your hypothesis will become your conclusion, and then your conclusion will become your hypothesis. Okay, how about question number 2, Mr. Labsan? Could you please state the contrapositive of this one?
If you are not staying up at night, then you are not studying hard.
Okay, very good. So see, it's very, very easy. Okay, so of course, as usual, after having this kind of examples, then we're going to have an exercise. Okay. Oops. Did I? No. So not yet. So this one has an answer. Okay. So later on, this one has a continuation, which is your C3. So this is your quiz and then examples, and then Seatwork. All right, so let's answer this exercise number 1. So we have this problem. If Aaron is late, then Bill is late. And if both Aaron and Bill are late, then class is boring. So suppose that class is not boring. What can you conclude about Aaron? So if you're going to analyze this one, so you will say that Aaron is not late because we have already assumed that class is not boring, right?
Yes, sir.
Because if class is boring, then Aaron is late. But since we assume that class is not boring, then Aaron is not late. But then again, we have to prove this one using a truth table. Okay. So the first thing that you need to do is this one, translate into symbols of logic. So you have to translate those statements into symbols of logic. So we have here letter P, wherein Aaron is late, and then letter Q, Bill is late, and then letter R is class is boring. So by having those symbols or statements, we can come up with this kind of expression. So if you're going to read this one, if Aaron's late, then Bill is late. And if P and Q. So in here, it can be not exactly as what we have in here. So you can say here, if Aaron's late and Bill is late, then class is boring. So as you can see, we've just removed the both and then the redundancy of the word late. So instead of having the late for Aaron and Bill, so we can just simply say if both Aaron and Bill are late. Anyway, those two are just the same. So we don't need to call this one. We don't need to justify, okay, that those two are not the same. Since this is not English subject, so we don't need to be grammatically 100% correct. Okay. So from there, okay, from that expression, so make a truth table, okay, or construct a truth table rather. Okay, so once you're done with that, okay, you can come up with the same result. Okay. So I will leave the analysis part to you guys once we're done with our meeting. But for now, let's just say that you have already come up with the same values of truth table. Okay, so we have 3 variables and then 8 possible combinations or 8 possible results. And then here are their results. So true, false, 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 true, 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 true. And then the next step that you need to do for you to be able to prove that Aaron is not late is remove the F or false entries in S. Because we have already assumed that class is not boring. Okay? Because what is this S? Okay? In here, we were assuming that class is not boring. So we have to remove letter F wherein class is not boring. Okay? And then step number 4, since class is not boring, okay, remove the entries in R. Okay? Because this letter R is the statement wherein it is saying that class is boring. And as you can see, we have true here, true, and then true. And since we know, or we have already assumed that the class is not boring, so this one should be false. Okay, or the remaining values should be false. Okay. And then once you're done in removing those true, then we can now proceed to the validate P, that is F, meaning Aaron is not late. Okay. So in here we can read this one as Aaron is not late and Bill is late, and then class is not boring. Then we could say that the entire statement, or if that is the setup, or if that is the thing that happened, then we could say that this one is true. Okay, since we have already proven using the truth table that this one is true. And then we could also say that Aaron is not late, and then Bill is not late, and then class is not boring, okay, which is also true. So that is already your like final answers when it comes to truth tables. So therefore, you could now say that Aaron is not late. Okay. Did you guys get that one so far? So we have 5 steps, and then all you need to do is just conclude whether our assumption is correct or no. Okay, using a truth table. Okay, so I will just repeat on what are the steps that you're going to do. So step number 1, translate them into symbols of logic. Okay, and then our basis will be always the assumption. Okay, in here we've assumed that class is not boring. So for us to be able to know whether Aaron is late or no, then we have to come up with this kind of expression. And then after having this kind of expression, then we can now construct a truth table. Okay, so this one is actually quite risky. Okay? So do not rush this one, because once you have one part that is already wrong, let's say this one, instead of putting here false and then you put here true, then it might affect your final answer. Okay, so you should be very, very careful when it comes to constructing a truth table. Right? So this is step number 2. Once you're done with this one, then you can now proceed to step number 3, wherein our assumption. Okay, since we've assumed that the class is not boring, okay, then we should remove the false statement in here. Okay, because we're trying to say that our assumption is correct. And then step number 4, since class is not boring, then we should remove the true statements for the letter R, wherein letter R is saying that class is boring. Okay. And then for step number 5, so in here we can validate that Aaron is not late, okay, because having 2 results, Aaron's not late and then Aaron's not late. The other one, Bill is late, but still Aaron's still not late. So in here we could say that Aaron is not really late. Right? Understood so far?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Mhm.
Okay, so anyway, if you didn't get this one, so you can always, read back and then try to understand what happened on our truth table step by step. All right. So once you already understood that one, then you can now answer this one, okay, which is kind of similar. Okay, so step number 1 is already given. So this is already your bonus. Okay, and then some of you might ask, so why do we have buts in here, sir? So you can just basically disregard this one. Okay, so this is just our assumption. We're in Andy is not mad and the refrigerator is empty. Okay, just like what we have on the first example. Okay, so answer this one also using Microsoft Word. So you can use tables. Okay, you can insert tables on your Microsoft Word so that you won't be having a hard time in answering one by one, okay, or column by column or row by row. Right? And also, you're going to have a Seatwork on this one. So prove associative properties using truth table. Okay. So in here, this one is super easy. Okay, just construct the truth table of this expression and then the truth table of this expression also. And then all you need to do is check whether they have the same results or the same values. Okay. So use Microsoft Word also in proving that those expressions are equal with each other. Okay. Are we clear so far?
Yes, sir.
Yes, sir.
All right. And the next Seatwork, okay, this one is also super easy. Okay, this is a converse and contrapositive. Okay, so we already have your statement here, statement S. If it's raining, then the ground is wet. So all you need to do is translate this one into symbol. And then letter B, translate this one into, or state this one rather. State this one into English, converse. And then letter C is the contrapositive statement of this one. Okay. So we have already have an example for those two. And then the same with letter A. So this one is super easy. All you need to do is construct a symbol. So again, you should always start with letter P, okay, and then followed by Q. So in here, we only have two statements or two separate statements. Okay. So are we good up to this point? So use Microsoft Word also in answering this one. Did you guys get this one? Understood?
Yes,
Yes, sir.
sir.
All right.
Yes, sir.
Yes, sir.
Okay, very good. So next we have here switching network. Okay, so this one is super easy. So switching network is basically just, you know, a normal switch wherein if it's open switch, then this line is not connected with this wire. That's why we call this one open switch. And then the other one is closed switch. So when we say closed switch, meaning there is now a flow of current on this line, or this line is connected with this line. Okay, so you can think of this one as a bridge. Okay, so if it's open, then there is no flow of current, and if it's closed, then there is a flow of current. Okay, so we have here series and parallel switches. So for series, we only have one path of current. Okay, and then for parallel, we have two paths for currents. So we can either pass through P or pass through Q. But in series, you have to pass through P and Q. So that is why we call that one in equivalent logic P and Q. But in parallel, we can say that it's P or Q. So you can pass P or Q. Okay. Easy, right? Very, very logical. Are we good? For series and parallel?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so for series, you're required to pass through all of the gates or all of the bridges. But for parallel, you have to choose either of those two. It's P or Q. And then we have this circuit's construction. So construct a switching network of the given compound statements. Then construct another switching network of the equivalent statement by applying the laws of logic. So we have here a given expression, which is quite long. And then if you're going to build the circuit, you'll come up with this one. So X will pass through P and R, or Q and R, or not Q. Just for you to be able to go to Y. Okay. So yeah, that's how you read this circuit. So you can pass through P and R, or Q and R, or not Q. Are we clear on this one, on how we've come up with this expression, or on how we've come up with this circuit? So this expression is equal to this circuit. Okay? Gets or no? Hello? Are you guys still trying to analyze this one?
Yes, sir.
Okay. P and R is this one, or Q and R is this one, and then not Q is this one. Right? So once you have once you have already constructed your switching network, then you can now simplify the expression, because that is the question. So once you're done constructing the network, then we can now apply laws of logic to simplify this expression. So from here, okay, we've applied inverse distributive. Okay, so from 4 variables into 3 variables. And then after applying this one, then again, they applied distributive law. Okay. So this not Q is distributed on this parenthesis or statement. So that is why we have P or Q and R not Q. And then P or Q and R, sorry, this one only. R or not Q. And then as you can see right here, we have two distinct connectives. So from here, we can actually apply connectives, okay, or associatives rather. Okay, so upon applying associatives, then we can now choose the parentheses in here so that we can simplify this Q or not Q. Okay, then once you're done with this one, okay, you can come up with the true value. Okay, Q or not Q is by applying inverse law. Okay, that's why we come up with this T. Okay, and then from here we have or. Okay, and then whatever is the value of P will be always true. So we can just simply remove P or here, or those two, this letter P variable and then this or connectives. So the only remaining variables are expression are T and R or not Q. Okay, and then again, since this one is N, then the deciding factor of our final values are on these expressions, R or not Q. Okay, so you can just simply remove this letter T. So that is why we come up with this kind of result or expression, which is R or not Q. Okay, and then from there you can now draw again or construct the switching network of this final result. Okay, so we have here R or not Q. So from there we can simply say that this expression is equal to this one, and then this circuit network is also equal with this one. Okay, did you guys get this one so far?
Yes, sir.
Maybe, so yeah, maybe this one, yes, super easy to understand, but this solution, maybe not yet. So again, I will leave this one as your self-study assignment, okay, but not recorded since this one is just an example. Okay, so once you're done in understanding this one, then you can now proceed and answer this Seatwork, which is very similar with this example. Okay, so construct the switching network of this one, and then once you're done is come up with the simplified expression. And then once you're done having a simplified expression, then you can now draw again the circuit network of that simplified expression. So you should have this kind of result. Okay, so we have two numbers for this circuit. All right, so this one is quite long, this one is quite simple. So in here you have to expand this one, okay, because there is no conditional or biconditional in this one in switching network. So we have to convert this one into N or into OR. Okay. And that's actually it for part 2 of module 1. So do you guys have a question or clarification so far? Question, guys?
Sir,
None,
ipopost
sir.
po ba yung Seatwork sa Canvas?
Ano yan?
Ipopost po ba yung Seatworks sa Canvas page natin?
Yes,
Or sa
you are
Facebook?
going to upload your Microsoft Word files in the Canvas. Okay. MS Word, hindi ibang format. Okay, so malalaman nyo na lang kung paano later on sa Canvas. Okay, so I highly advise you guys to practice, and practice. Okay? And then at the same time, memorize some of the formulas. All right, and then familiarize. All right, so that's it for the part 2. So if ever you have a question, so feel free to message me on my Canvas account or to my Facebook